Hey guys, so welcome back again to for doing the Leetcode daily challenge, and let's start with our today's question and let's see what we have. So we have a medium question and which says count a number of complete components. So yeah, it's a graph question again, and there are components given, and we have to find the complete component. So yeah, what does a complete component means? So connected components or complete component is a subgraph of a graph in which there exists a path between any two vertices and no vertex of the subgraph shares an edge with the vertex outside of the subgraph. Okay. So see, basically in this example all the components are connected ones. We can see that because if this is a component, yeah, 5 is a component, it's a single node, so it's obviously a complete component. If there are two nodes, there is an edge between them, that's one complete component. And in this one there are three vertices and there exists a edge between every two vertices, means one should be connected to 0 and also 2. Same for 0, it should be connected to 1 and 2, and same for 2, it should be connected to 0 and 1. So every node has a edge to the any other node of this component, and if not, we cannot count it as a complete component, because in this example we can see that this one is a complete component, but this is not, because there does not exist a edge between 5 to 4. See, path exists 5 to 3, 3 to 4, but an edge, direct edge, does not exist between 5 and 4. So it's a undirected graph basically. So firstly we can create a adjacency list for this vector of vector int, and that will be adjacency and the size will be n. And adjacency and size is n. Now let's form this, and that will be auto e of this edges. We can say that adjacency e0 dot pushback e1 and adjacency e1 wait adjacency e1 dot pushback e0. Yeah, so that gives us that it's a indirect graph, so there's the edge is from a to b or b to a. We have to consider both of the cases. Now see, one thing is simple, that either using BFS or DFS, we just need to iterate every single component. Like we go to a node, we iterate everything connected to that node. But what we have to check here is that the number of edges or the number of places we visit from that node should be equal to the component's whole size minus of 1. Means if we start with a 0, okay, because the nodes are from 0 to n minus 1. Yeah, if we start with 0, how many edges are there that are going out of this 0, or how many nodes are there which are directly connected to 0? There are two nodes, 1 and 2, right? And what will be the adjacency list containing? Adjacency list will also contain these same nodes, right? If the size is equal in its adjacency list, for adjacency list, adjacency of 0 is 1 and 2, it has size 2, and while doing BFS we will also visit only two other nodes other than 0, that is 1 and 2, because anything else is not connected to it. So if the size is same to the adjacency list and to the nodes we are visiting, that means that this is a complete component. And if not, the size is not equal, means adjust, in this case the adjacency of 5 will only contain 3, because it's directly connected to 3 only. But while doing the BFS for 5, we will go to 3 and we will go to 4 as well. Okay, so the size of this adjacency list for 5 is not equal to the number of nodes it's visiting. It's visiting two nodes, but other than 5, two nodes other than 5, but in the adjacency list there is only one node, 3. So that is why it is not a complete component. So obviously through BFS or DFS we just have to iterate it, and let's just say this is our answer. We'll be counting the number of complete components. Firstly we can do what is, we can Let's form a vector of visited first. Visited n and 0. We will go to each node, I less than n, I plus plus, and what we will be doing is that we'll go to every node. If it's not visited, yeah, if the node is not visited, then we will do the BFS for this. And BFS will do what? Adjacency list it will take, visited array it will take, node it will take. And now in this BFS we have to calculate the number of nodes it's visiting. Okay, so for that purpose we can do one thing, and that is yeah, plus plus, yeah, int number we can say inside this only, yeah, int visited, the number of nodes it will be visiting. Okay, and send this also to this. Now after BFS we will have a count that is visited, and we also have already had this adjacency list. So after this what we will be doing is that if the adjacency of this I dot size, no, yeah, see, in this method what we will be doing is that we'll go to each node. Okay, but we have this condition applied here. So while iterating for 0, we have visited 1 and 2. So for 1 and 2 we won't be again doing this thing, this if condition. So that will be the wrong thing to do, because for 3 it's fine, but for 4 and 5 it's not fine because they do not have a edge between them. So when we visit 3 in the BFS, 4 will be also visited, so we won't be going to 4 again, and we will say that yeah, it's already connected component, so it should not be happening. We have to keep track of all the elements we have visited in the BFS. So for that the count won't be enough, we have to make a vector of it. Okay, we have to make a vector where we will store the elements which we have, the nodes we have visited. Okay, now after this, if there's a vector, then we will run a for loop. That for loop int node of this visited, and if the node of this visited array, for every node of the visited array, if adjacency of this node dot size is not equal to the, yeah, the visited dot size minus 1, because one itself, one value is for itself. Okay, when we are iterating with 0 count itself also 1 as visited, so minus 1. Then let's take a flag here, bool flag. Initially it's true, but if this condition happens, then flag will become false, yeah, and we will break. For this whole component we don't need to do anything. Okay, and after that, after completing this, yeah, we'll break out of it, and we will break out of this also. And if the flag, okay, flag is here only, so we can do this here. So if the flag is true, then we will increment our answer, that is count, otherwise no, and we will return the count. Now let's try to write the BFS function. Okay, void BFS, it will take this adjacency list here, and it will take the vector of int visited here. It will take I here and it will take the vector of visited visited here. Yeah, perfect. And in this obviously we will take a queue, and queue, we will push this initial value inside it, and we'll make this as 1, and while queue is not empty, what we are gonna do is int f is q dot front and q dot pop we will do. And what else after that is that we will insert this in our visited. Now we will look for the neighbors. For auto node of this in the adjacency of I, will go there, and if it's not visited already, we will just push it into the queue, queue dot push node, and okay, we can also do that. Visit of node also equal to 1. Yeah, that will work, I guess. Yeah, perfect. So vector for this, okay, let's try to run this. I think it's all fine. Okay, what's happening? Why the internet is not working? Okay, my internet is not working, so let me just do something else. Yeah, it's good now. Reload this and try to run this. Okay, this case is failing. Let's see why it's failing. And the second case, the output is coming out to be 2, but it should not be. Okay. Count is 0 for the second example, we'll see. Okay, and what we have here is that we are visiting all the nodes of the visited, and we are checking that if visited dot size -1 if equals to the adjacency of that node dot size. Adjacency of that node will be perfect. Now let's see what the see out the visited dot size first thing, and yeah, make it here visited dot size -1, and in the next line let's print see out of node and its adjacency of node dot size. Yeah, let's run this for Yeah, run this for this test case. Okay, so the visited for we are using 0 first. 0 for it's perfectly fine. 0 is the element, 2 is the size. For 1, 2 is the visited size. 0 2 0 2. Fine. One component is this for this example. Now the 534 for this up to there it's fine. Perfect. After that for 3 the size is 2 3 2. Perfect. These two values 2 and 2 should be equal. Now again it's going to 3 again. Okay, it's going to 3 again. Okay, I guess it's a problem. The adjacency of 5 must be 1. Size should be 1. Adjacency of node 3 is 2. The element is 3, 3 and 3. Again and again and again. Yeah. I got the problem where the problem could be. Now let's try to do this that if it's not visited we are calling the out yeah, perfect. Mhm. What we are doing in the BFS is we are pushing it out and we are visiting it as true, then we are taking the front, we are popping it, then we are pushing it into the visited thing, and then if the visit and then okay, if it's not visited we'll push it and make it as the visitor also true. Yeah, this all is fine, but after 3 when the I is equal to 3, y is not going to 4. 3 is perfectly fine. See, 3, this is perfectly fine. After this, okay, okay, it comes here. Okay, it's adding the count here. Okay, this is the problem. This is the problem. Then, what could be the problem here is that, hmm. We should not be making it true here. Okay, for 3 it checked and it's making it 3. Yeah, for the 3 let's print out the visited of it. Okay, let's print out the visited of it also. After this yeah, for int I0 to I less than visited dot size I plus plus and see out visited I and not take it I, take it as J, visited J and see out handle. Yeah, when we go for 0, when we go for 0 the visited will be what? See, initially it is 0 0 and 0. Why is this happening? Okay, okay, yeah, we should print F here. Yeah, I got the problem. Shit, these small things. Never mind. It was a really easy question, but I just fucked up here. I couldn't just caught that small thing. Yeah, yesterday the same mistake also happened. So yeah, it's not good to do such mistakes, because uh, 10-minute question took 20 minutes. Now let's try submitting this. I don't think any problem is gonna be there for now. Okay, there is a wrong answer. That's good. Well, 4 are there, 1 and 0, 2 and 0, 1 and 3, 2 and 3. But 3 and 0 are nowhere connected. So if we try to make a diagram of this, so what we have here is 1, 2, 0, we have a edge, 0 to 2 we have a edge, and 3 is here, it's having edge with 1 and 2. Now we start with 0. Now for 0, we'll see that adjacency is 2, and how many we visited, right? How many we visited. So do this and use this test case and run. Okay, so for 0 the adjacency was 2, and the number of nodes it visited, so visited minus 1 is 2. That 2 nodes it visited, but it visited 3 nodes, isn't it? Yeah, the size should not be equal here, because visited dot size must be 4. Yeah, it should be 4. If we see, we are pushing back f, means we are firstly pushing back 0, then 1, then 2, and then 3, because we are visiting all the 4 nodes, and it becomes the size of that visited dot size is 4. Okay, let's do this also and run. So the visited array is 0, 1, 2. Why isn't 3 here? Okay. Okay. Yeah. I have no idea why this much test cases passed, even after that silly mistake. No idea about that. What test cases are these? Well, this is good now. Okay. Okay. We can remove this, and we can remove this, and now it should be submitted. Yeah, perfect. So this is done for the day. Count the number of complete components. It was easy question. It was just my silly mistake which take more than half of the time. So I will try to improve on that also. So that's it guys. Keep doing Leetcode. Bye bye.